Okay, so hi everyone. I do believe we are streaming now. This is Miss A. So I was looking back through my old computer science streams from the past couple months, and I kind of realized I'd actually skipped over lesson 11. So I'm gonna go back and do that one right now. That was kind of a funny moment. I was sort of like in the last kind of few days before I moved, and kind of wound up being like a weird kind of jury rigged situation, and I kind of lost the video, and it was not great. So we'll just do this again. So as I said, we're going to take a look at lesson 11. So this one was a continuation of the if statements that were started off in lesson 10. Thanks, Spectrum Internet. So, I don't know what it's been the last couple weeks or so. Internet's just been kind of testy. It's been going out every so often. I guess, it makes sense. Everyone's at home. It's a weird kind of load on the system compared to before. And I think a lot of people don't realize this, that say like a lot of corporate internet infrastructure and like residential internet infrastructure are not really reliant necessarily on the same parts. At least you have to imagine the internet like infrastructure, like the stuff, the like wires, the optical fiber that kind of gets the internet to and from your house. That's kind of, you got to imagine this very, very branching system. And corporate and residential stuff, they will, or sort of the service providers who provide for those, they'll kind of have different infrastructure for them. So it actually does kind of make a difference to the system when you have, say, like a lot of people using their residential internet versus a lot of people at work, in buildings that have those other kinds of like commercial hookups. So let's take a look at lesson 11, if-else statements. So if statements, right, which we kind of see in lesson 10, is this very, very, very basic nugget of a decision. In just like the simplest terms. If you see this, do this. That's it. One single instruction, right? One kind of single decision that's made. Do you see this? Okay, then do this instruction. That's it. Very, very simple logic. Like the most basic thing that can still be called like a decision. And what we learn in this lesson kind of is the first step to really broadening that, to create more interesting and, kinds of situations. So here we're kind of introducing, well, all right, in the basic decision, it's if, what could we pick? If I, eat out too much, I'm going to spend too much money, right? Or I'll run out of money at the end of the month. Something like that, right? Well, let's forget that one. So let's keep going. If statements, like I said, bare minimum. If this thing's true, do these instructions. Okay? Kind of like, here's a good example. If it's a school day, log in to Google Classroom. I guess a few months ago I would have said go to school. Weird times we live in. But, that kind of an idea, right? Is today a school day? Yes. Then, log into Google Classroom. But what happens if it's not a school day, right? That's the part that's left unclear. Like in this example that they have up, again, thanks to CodeHS, great example here. You guys make great videos, love it. If the front is clear, move. Well, what happens if the front's not clear? That's kind of the big major question. There's no backup. It's purely like run this instruction. If the conditions are right, otherwise don't do anything, right? There is no follow-up. Any code that comes afterwards is just going to happen whether or not that if statement runs. If the if statement checks out and, you know, it moves, then it can resume and keep doing the stuff that follows. If it's not clear and they don't move, then it'll still kind of resume. Okay, but there's no kind of backup plan, right? Either you do it or you don't. So that's kind of boring, right? That's kind of limited. And so the first way we can do this is say else statements. If this is true, and you can think of else like otherwise, or in the other case, or really like the way eventually you're going to think of it, because we'll be able to kind of chain a bunch of these together in order to make kind of more well-developed, kind of complex statements. So for instance, one thing you can think of is a couple years ago, or I guess, oh my God, it was last year at this point. Feels like a decade ago, but last school year, I had some of my programming students make a text-based adventure game. And so when they're making the interface, they kind of made it like a multiple choice. So say, you know, it was a sort of killer in the woods type of setting. And so what they did was, it was like, you know, you see a creepy looking cabin in front of you. A, enter the cabin. B, look around. C, go back the direction you came from. D, look in the inventory, something like that, right? You've got a bunch of different options. And so you have to get the computer to kind of decide, well, what am I supposed to do when the user types B, right? How does the computer know that the user typed B? And second, right, how is it going to follow it up? Okay. And so you can have a bunch of these, right? A leads to one thing, B leads to another thing, C leads to another thing. But then we always end up with a kind of a problem of, well, what happens if they just put in garbage, right? What if the options are A, B, C, D, and the user types in the % symbol, right? Or a semicolon. What does that mean? What is it supposed to do? That's where an else statement is really great. An else is just a big catch-all, basically saying, like, if no condition has triggered, if nothing has come up true that you were checking for, then here is just the option of last resort, right? If you get to this point, this is what you're going to do. But only if nothing else checked out. So else statements are really, really useful for, say, stuff like error checking. You know, if you get a correct input, give the correct, go on to the next step. Otherwise, spit out an error message and stop the program. That's where else statements are great. It's that big kind of catch-all, if all else fails, do this kind of option. So in this case, they've got, if the front is clear, Karel should move. That makes sense. Well, what if it's not clear? That's where the else kicks in. Well, else, have him turn left. Okay, so basically he's not going to do very much, but, he's just going to kind of face upwards. But it gives you a backup option, right? He's not just going to stop when he can stop moving. There's this one kind of final action that he can do, but only if he couldn't move. I always do this. I just always do that. All right, so, okay. Yeah, so this is a really important part, right? Handling different types of worlds. I just use the example of, say, like user input, right? So for a typical, more like real world programming example, that's kind of the, those different types of worlds that you'll be dealing with. Like, what kind of input is the user giving you? Literally just like, what are they typing? If they type one thing, you want the program to respond one way. If they type something else, you want it to respond a different way. This is that part of like what makes a computer feel real, what makes it feel responsive to us, is the way that, say, like, it can act differently depending on what you're doing, right? That makes it feel like a genuine interaction and not like you're just like pulling strings on a puppet, right? It makes it feel more like talking to a human being, or maybe like talking to an animal, or like playing with an animal. I guess most people don't talk to their pets as much as I do. So yeah. Again, good point, right? This helps us make a move from specific to general problems. And what does that mean? I think, again, like a computer is at its best, and a computer program is at its best when it's able to handle a lot of different things without help, okay? A program that just does one thing really specifically, and you have to, like, is always going to, one, be more limited as to the types of problems it can solve, right? Because generally speaking, we want to solve as many problems with as few programs as possible. We don't want really a tool for everything. Like, that's how come they managed to sell us billions of these things, right? It's one tool that does everything we need, and that's a very appealing thing for people. We always will prefer that when we can get it, over, say, like, you know, the word sort of like single use sort of things. It just adds complexity. The second kind of part of that is about, oh my God, totally lost I totally went off. I started thinking about cooking shows. When I think about multi-use versus single-use things, I think about this guy, Alton Brown. Great cooking show. It's called Good Eats. Highly recommended if you like watching food stuff. But yeah, got kind of distracted there. So talking about different worlds, specific versus general problems. Right, we like to have multitaskers, but also, generally speaking, like, you only want to have these very specific problems if they are, like, very important on their own, right? And that's always going to be, like, a big investment, and that's typically going to mean there's, like, a lot more complexity there. And it's always going to be more complex for the user to use. Sort of general use things, like, because think of it this way. If I have a program that needs some, let's think of it in terms of, say, like, bureaucratic forms. Like, say you go up to the DMV or something, right? And you go up, and a lot of times, and especially anybody who's worked retail or worked customer service or anything will recognize this. Like, I would bet, like, most people who walk up to the DMV, you know, maybe some of them know what they want. A lot of them probably don't know what they want, right? And so if the DMV person can handle all of, you know, a lot of different things, then that's fine, right? Then the user can, like the client, the person at the who's trying to get service at the DMV, you know, it doesn't matter, right? They can make some vague kind of like, oh, I don't know, like, I think I kind of have to do this, but I'm not so sure about it. Like, I think I have to update this document, but then, like, I don't know, I got sent this other thing, right? They'll have these very vague, kind of half-remembered sort of things that they need to do. And if you have, like, a person who has access to all of the different tools in the office, right, they are probably going to be able to kind of find the right thing for what the user's doing without that user having to do much work. Whereas, say, if it's the kind of DMV office where, say, they make you bounce around from teller to teller and be like, oh, that's not my thing, go over there, talk to that person, but make sure that you have, like, these forms of identification plus, like, this form filled out plus this other thing, right? If you have these very, like, this one person only deals with this one problem, this one only deals with this one problem, then if you don't have a clear idea of what your problem is, then it's going to take a lot of work to fit that problem into that tool, right? To say, like, to translate your problem to the person at the DMV. So generally speaking, yeah, like, general things are going to be harder to program, but that's going to make it easier for the user, right? I think that's kind of the big picture there. Specific things are typically going to be, are going to need their users to do more work to fit what the program needs. because it's more specific. It can't handle too many different kind of things. Like it wants its inputs to look one way and one way only. And then it's up to the user to do that. So this kind of logic, this if-else structure, and the things we can build out of it, right, that's how programmers create programs that can behave that way. That can be easier for the user, that can, like, we all love stuff like that. Like, I think, you know, if you're a student of mine, you're definitely way too young to remember search engines before Google, but like this whole thing of just asking a question in plain English just like did not exist. You had to type in, say like you had to specify, are you looking for an author or a title or a subject? If you were looking for, say, something specific, you had to use like different kind of marks and stuff, and you had to use like think about what kind of keywords would most be like useful for finding this thing. And so like it was harder to find what you wanted, but it also took a lot more work to just think of how to look up a simple thing, right? Whereas Google, right, there's more done on their end. It's a much more complex beast, the kind of stuff that underlies that, than what it used to be back in the 90s. But at the same time, you know, it makes it a lot easier for the users, right? At this point, we're basically trained that like whatever the first thing that Google finds for us is generally like 90% of the time is the thing that you use. The other 10% of the time, maybe you go for the second result, and almost no one goes beyond that. Mostly because most people feel like they don't have to. People would not kind of be in debt to Google the way they are if it kind of didn't work well for them. So there is that there, even though I might sometimes be a little down on Google. Okay, so let's take a look at an example of an if-else statement. Let's explore this example. So we have a start function, as usual, right? Starts up here, we go down, ends here. Then what do we see? So we've got a move, and this is going to happen, right, regardless of what's going on. There is no case, there's no way this world can look that doesn't have that. So here's what we see, right? If front is clear, it's going to move. Otherwise, it'll turn left. Okay, so what's going to happen here? If we start, okay, he moves. Like I said, there's no decision to be made there. That is going to happen. It's not inside an if statement. Now we get to the if statement. So now he's asking himself, is my front clear? The answer is obviously no. There's a kind of an obstacle in front of him. So he's going to skip line 4 and go straight to line 5, right? Or to line 6, right? What's in the else statement, okay? Because it didn't work. It wasn't true. So he's going to turn left. Well, what happens if we take out this first move? Okay. Well, now we just get straight to the if statement, and now this is true. His front is clear, so he's going to move. Is he going to go into the else? No. It's one or the other. And the if statement takes precedence, right? That's the one that's going to be looked at first. Is my front clear? Yes, go ahead and move. No, go ahead and turn left. Again, we're always thinking of these conditions. I kind of mentioned this in some of the other videos. That the conditions need to be picked in terms of that, like what needs to be true to make the action happen. What should he look for in order to know to do something? And so that's always why we kind of have the yes case first. Like, is his front clear? Yep. Then go ahead and move. All right, so let's take a look at the second example. Okay, so he's going to make a J. This is a really interesting one. All right, so this might look kind of complicated at first, so let's break it down. There's a lot of repetition here. Check, ball, move. Check, ball, move. check ball move, check ball move, check ball. Okay, so they probably could have replaced all of this repeated code with a for loop, which you hopefully tuned in for lesson 9, right, for loops. And that'll just kind of take care of that repetition a little more quickly. But more or less what's going to happen, he's going to check if there's a ball, and then he's going to move. And he's going to do this 4 times. He's going to do this in basically each of these 4 spots. Is there a ball here? And so see, I have not even read what this function is, but I already know what he's probably going to do. That's the power of a really nicely named function. You know, people should be able to tell what it's going to do. So let's actually dig into its guts and see what it does do. So if there's no ball present, it's going to put down a ball. Otherwise, it's going to turn left. All right, so let's take a look. What's going to happen? So he's going to start by checking if there's a ball. Is there a ball here? Or actually, are no balls here? Right? People, we always tend, I think we more often than not tend to ask things in that positive form, where we're kind of always saying like, is this there, right? Is there a ball? We rarely ask like, is there no ball? Although we might maybe say like, is the spot empty? Might make sense, right? So is there not a ball there? Yes, that's true. There is no ball there. That condition is true. So it's going to put down a ball. And now we're just going to skip over this turning left and go back, sort of resume where we left off. So now he's going to move to that next spot. He's going to check if there's a ball there. And no ball's present. No, it is not true there are no balls present. So this statement is false. If somebody asked, is that spot empty? You would say no, false. So instead of putting a ball, I did not mean to do that. Let's go back a few steps. Okay. So now instead of putting a ball, he's going to turn left. He's going to move. He's going to check if there's a ball. Check for no ball. If there's no ball there, you will put a ball. Okay, now he moves. Check, is there a ball there? Is there no ball there? That is also true. So he puts one down. Now he's going to check, is there one there? Yep, there was no ball, so put one. Bam, done. Here's my question. How could we change this so that instead of using the no balls present, we use the balls present command, right? Because this was kind of where my brain kept going, using that name, check balls, see if there's a ball, ask, is there a ball? This would seem to make more sense to us. And we can do it. Since this is a yes-no question, you can absolutely flip it and still get sensible answers and still lead to the things that you want. We just have to think. So now the question is, well, if there is a ball present, we don't want to put a ball down because there already is one. Instead, we want to turn left. And for the else part, right, if there is not a ball present, that's when we want to put a ball. So really all we have to do is just kind of flip what the if statement leads to and what the else leads to, which should make sense, right? All we did was flip the direction of the condition. Instead of asking whether there are no balls in the spot, now we are asking if there are balls in the spot. We're just going to get the opposite answer. So we kind of flip the actions that they lead to. So now let's run it and let's see if we get the same result. We absolutely do. Cool. Excellent. Thank you, Karel. So there you go, right? When you're big thing that I'm going to want you guys to watch out for is picking a condition that makes sense to the problem. Okay, here it makes sense to look for whether there are balls or not. In the last example, it made sense to look for whether the front was clear or not. We would not really want to mix those up because they're going to lead to very different types of decisions than what we're expecting or what we're intending for. And again, keep in mind whether when you're looking at the conditions of whether you want to use the sort of the positive ones. Is the front clear? Is the left clear? Is Karel facing south? Is Karel facing west? Are there balls present? Versus the negative ones. Is the front blocked? Is Karel not facing north? Are there no balls present, right? Keep in mind, you can get away with picking one from one side or the other as long as you're careful thinking about what conditions should lead to what action, okay, and making sure that those connect. Again, if you have any issues, you can always hit more conversation and send me a note, and I will, be able to get back to you. You can leave a comment here. That would be lovely. And yeah. Thank you guys so much. I'll be back hopefully on Thursday to resume with lesson 13. Okay. Hope you guys have a wonderful rest of your day.